Alright, welcome to our Exam 3 study review. Just a note to start us off here, as in the past, these videos are copyrighted by me, so they're only for use for you guys. Please don't, put them on the internet, post them to, the homework sites like Cramster and things like that. I put in this time for you guys, not for everybody else. So let's go ahead and get started here. As we're getting started, all your formulas here I've got. This is the formula sheet that you get with the test. So there's not really much that you have to remember for formulas. There are a couple small things on the way that I'll point out. Okay, so first off here we're looking at geometric series before we get started into the finance stuff. And here it says fill in the missing terms to form a geometric. So remember, geometric here means that you multiply to get to the next term. And then state the value of r. Remember, r is your multiplier. And the easiest way to find that multiplier is just to take any two terms that are next to each other and divide one by the previous. So here we've got 3 and 12 next to each other. So if you didn't see, in going from 3 to 12, that was just multiplying by 4. And here we can look at it and we can say, oh, our multiplier is 4. R is 4. If you didn't see that, if it's not easy to see that, then your R value, you just take any term and divide it by the one previous. So in this case, 12 divided by 3 is 4. Okay, so if these end up being decimals or something like that, then that's your multiplier. That's how you get it. So then we want to continue multiplying by 4. So 4 times 12 is 48. And then, you can double check with your calculators here. 48 times 4 should be 192. And I'm just double checking that. Yes. And then times 4 again. So 192 times 4, 768. So this is a 768. So there I'm just using the definition of geometric series. So that's something that you need to know. That's not on the actual formula sheet, but it's kind of built into the formula. Okay, so then for this sequence up above, we want to find A15. So A is the variable for the term number. So this is the 15th term, and then the sum of the first 15 terms. Okay, so for A15 there, we need the nth term formula. So that's up in a geometric series. This is the nth term. You start with the first term and then you do the multiplier 1 less than the number of times. So let's go ahead and get that written out. So we're using an equals a1 times r to the n minus 1. And then what we're finding specifically is a sub 15. So this is the 15th term. So A1 is your first term, so that's 3. So let's write that out up here. A1 is 3. And then we need R. Okay, well that's our multiplier. We've got that right here. R is 4. And so if we do our plugins, A1 here is then going to be 3. And then our base of our exponential there is 4, so times 4, and then the power is 1 less than this number, because see, n minus 1, so this is 15, this is going to be 15 minus 1, 14. And then just key that in the calculator. This is 3 times 4 caret 14, or 4 y to the x 14, and you should get 805, 306, 368. So 805 million. So that thing grows pretty fast. So that's that exponential growth. Because remember, these things are called exponentials. 4 is the base and 14 is the exponent. Okay, then we also want the sum of the first 15 terms. So that's asking us for Going back to geometric, it's asking us for S sub n, actually S15, so we're using this formula. So we're using Sn is A1 times 1 minus r to the n over 1 minus r. And so for us, we know all of these values. Well, here, let's back up here. So then for S15, sum of 15 terms, our A1 is 3. And then in the numerator here, this is going to be 1 minus r is 4. You know, I just realized something. An equivalent way to write this expression, and these are equivalents. You can use either one. Is a times r to the n minus 1 over r minus 1. And I can't remember which one of these we used in class. But let's go ahead and use this one for right now. So this is going to be 1 minus, and let's see here, 4 is our base, and then n, that's the number of terms, that's the 15, so 15th power, and then on the bottom 1 minus r. So now you got to make sure that you do this 15th power here before you subtract from 1. Actually, I'm thinking we did it like this, because, you know, common mistake is that students will include the -1 up in the power like it is here, and that's not what you want to do. Okay, so this top here, that is not the same thing as r to the n minus 1 power. See here, the -1's up in the exponent. Here you get the answer, raising it to the power, and then you subtract off the 1. Okay, so make sure that you do it that way. So either one of these, either 3 times 1 minus 4, whoops, this down here should be a 4. Should be a 1 minus 4 there. Or, you know, equivalently, whichever one you want to use, 4 to the 15th, subtract 1 over 4 minus 1. The advantage of using this one is that you're less likely to take this -1 and put it up into the exponent. So let's use the second one there. Yeah, this is the one that we actually used in class. So this is the one that you're going to see tomorrow, that version of it. Or for the test. So we do 4 to the 15th power, subtract 1, and then this is divided by 3. And, actually, this is, 4 minus 1 is 3 down here. And then these 3's cancel. So that works out nice. This 4 minus 1 is 3. So this is just 4 to the 15th power, and then subtract 1. And if you do the calculator work there, you get 1,073, 741, 823. Okay, and if you're not getting this, then you probably took this -1 and you put it up in the exponent and did 4 to the 14th power. Okay, you want to get an answer to the exponential and then subtract 1. Okay, let's see. Next up, we've got some estimation problems here. So you're saving $400 a month, and we want to know about how much will you save in 10 years with compound interest. Well, you're going to save your payments that you save at $400 a month plus some interest. So we want to figure the total of the payments. So your total payments here, this is just an estimation, are going to equal n times p. And the number of payments is 10 years, so this is going to be n equals 10 times 12, which is 120. So you've got 120 payments times 400 a month. And if you do the calculator work there, you get 48,000. Okay, so this is $48,000. Okay, now this is a medium-term loan. 48,000. I'm sorry, medium-term savings, medium time period. We got 48,000 in payments. We know that our answer is going to be more than 48,000, so this guy's out. At a really good interest rate, 7%, this would double in about 10 years. It's not gonna be a huge amount of interest because it's not like 30 or 40 years of savings. But if this whole starting amount, 48,000, was in there for 10 years, it would probably almost double, which would be 96,000. But we're not starting with 48; we're starting with 0. So this is not going to be anywhere near a double. So it's going to be 48,000 plus interest, but it's not going to be anywhere near $80,000. So this is too high. This is too high. It's got to be 65,000. All right, next up we're borrowing $75,000, and it's a 30-year mortgage. Okay, this is a long time frame. How much will your payments be over the 30 years? Okay, so remember, your general rule of thumb is at a high interest rate, your payments are going to be 3 times 75,000. So that's going to be the high end. That's one of our general rules of thumb, so that's not from formulas. And 3 times 75,000 is 225. And we were saying at the low end, 2.5 times the 75,000. So if you did 2.5 times 75,000, that's 187. So 2.5 times your 75,000 is 187. So you're in a range of 187 to 255. This is the only answer that's in that range. Okay, this one's too low. That would be like maybe a 20-year mortgage. So that's just general rule of thumb. Okay, next we're on to the problems. Okay, notice your directions here. Choose the formula from the sheet, write the formula. So you want to write which formula you're using, show the substitution values. Now some of the problems are substitution only, so that means just plug in the values and then leave it so you don't have to do the calculator work. That's just to kind of shorten your time a little bit here. Okay, so here you inherit $12,000 from your long lost Aunt Matilda, and you're going to use that to pay for your tuition next semester, right? And you decide to invest this in a utility stock. So those are like, electric stocks, gas companies, things like that. And they pay an average return of 8%. And we want to know, what will the value of your stock be in 4 years if interest is compounded quarterly? Okay, usually these utility stocks, when you own those, what they do is they take part of the profits and they pay you back each quarter. It's every 3 months. Now most of the stuff I do is going to be monthly, but I'll probably throw one problem in that's either quarterly or semi-annual. So quarterly here means that M equals 4 instead of 12. So you're going to be figuring a quarterly interest rate. So first of all, what we do is we go over to the formula sheet here and we try and see, which category is this in? Is this a single amount? Is it regular savings or is it loan? Well, it's not a loan, okay, because you're getting the money. Is it regular savings? Well, it doesn't say you get $12,000 per month. It says you just get $12,000. Okay, so it's got to be single deposit. So that's the first thing you do. Which category? So you know it's single deposit. Now look at the question that's asked. What will the value of your stock be? Okay, that's asking about future value. So we go back here. It's single deposit. We want future value right there. Okay, so write down your formula. So future value is your present value, and then 1 plus r to the n power. Okay, now let's get let's get some of our substitutions down. So 12,000, that's going to be your start amount. So PV is 12,000. And let's see here, 8%, that's your APR. So this is 0.08. We already said M equals 4, so when we calculate our R here, R is going to be a quarterly rate, so it's going to be 0.08 divided by 4, which is, instead of divide by 12, divide by 4. And that works out nice. That's a 0.02. And then the last thing we need here is N. So N is going to be the total number of quarters, not the total number of months. So N is going to be, it's asking you here 4 years. So it's going to be 4 years times, instead of 12 months per year, it's 4 quarters per year. So it's 4 times 4, 16, not 48. And then this one's a substitution only, so all we're doing is plugging in and we're leaving it. So your start amount, 12,000. And then 1 plus, your R here is 0.02. And then your exponent is 16. Okay, and then I would encourage you to key that into your calculator and double check and see that you get this answer here. Okay, but since this is a substitution only, that's where you end. So I'm not having you do calculator work on that one. Okay, number 5. You have a goal to save. Okay, so we're saving. And $8,000 in 5 years to use as down payment on a house. 5.5% APR. What monthly payment would be required to reach this goal? So you're making a monthly payment. Okay. So this is going to be regular savings. So you go back over here, see it's not a single deposit because you got a goal to save that much. It's not a loan, doesn't mention a mortgage or a credit card or anything like that. So it's regular savings. Now inside of here you decide which formula do you need. Well, it's asking you have the goal to save. The goal is the end amount. That's FV. So it's going to be first formula. If it asks what's the interest, that's I equals. If it asks what's the payment, it would be P equals. And if it asks how long, it's N equals. So first find your category and then look at the question. So we're using this first guy here. So P, 1 plus R to the N minus 1 over R. Okay, so our future value here, write down your formula, is P 1 plus R to the N power minus 1, and then this is over R. Okay, and the P is out in front, so this is times out in front. Alright, so let's start writing down some of our givens here. 8,000, that's your goal, so that's your end amount. Oh wait, I'm sorry. The question says what monthly payment. So we want to use, going back here, it says what payment? We want to use P equals. Okay, they gave us the goal. They gave us the FV. We want P. Okay, so let me take this guy here and I'll copy it over. Be easier. Bring that guy down. So write your formula. That's the one that we're using. Okay, because it says what payment, that's going to be a P equals formula. So now they gave us the goal, that's the end amount. So our future value is 8,000. And 5 years is time. We'll use that to figure our N. APR is 0.055. And let's see, what else? Oh, it's monthly. So that means that when we figure our R, we're going to divide by 12. So this would be 0.055, and divide that guy by 12, And I don't think that works out to be a nice rate. No, it doesn't, so we're going to leave that. And then our N, total number of months. Okay, well it's 5 years and then times 12 months a year. So that's 60. Okay, now we do our plugins. So future value is 8,000 times our 0.055 divide by 12, and then downstairs 1 plus our 0.055 over 12. That gets an N power, which is 60, so 60 power, and then minus 1. Okay, so now we key this in the calculator. So if you do 8,000 times 0.055 divided by 12, get an answer there. You'll get 36.6 repeating, so 36.66666. So you can key this in all at once if you're comfortable, or do top and bottom separate. I usually will do top and bottom separate when I'm doing them. And then down here, you want to do work from the inside out, 0.055 divided by 12 equals plus 1 equals, and now do 60th power, so caret or y to the x 60 equals, and then subtract 1. And you should get 0.315 703 772. Okay, and then divide these guys. You know, you've already got this in your display, so you can use the answer key. And if you do that, you get your 11614. Okay, and that's what we were looking for. So I encourage you to key these in and make sure that you're getting the right answer. All right, number 6, you can afford a mortgage payment of $700. Okay, so they gave you a payment. This is a mortgage. Okay, so that's the loan. Keyword there. So it's in the loan section. You can afford a payment of $700. What amount can you borrow? Amount that you can borrow, that's your PV. So we go back over here to formulas. It's not single amount. It's not savings. It's a loan payment. So it's in this section. And then the question that they asked again here was, what amount can you borrow? The amount you can borrow, that's your PV. So what we want to use here is the first formula, PV equals. Okay, so let me copy this guy. So we got it. And I will bring that over. Okay, so that's the formula we're using. And now let's write down our knowns. Okay, so it says your payment's 700 a month, so P equals 700. What amount can you borrow? That's PV, that's what you're looking for. 20-year mortgage, we're going to use that to figure R and N. Or I'm sorry, actually N. 8.5%. Okay, so that's our APR. 0.085. And then we need R. So R is our monthly rate. So this is 0.085. And we're dividing by 12. And that one is not a nice rate. So, but actually, this is a substitution only. So we'll just leave that. And then N, our total number of months, is going to be its 20-year mortgage, so 20 years, and times 12 months per year, 240 months. Be glad when that baby's paid off. All right, now we do our plugins. So 700 goes out in front. That's our payment. And then you got to be a little careful here. Times 1 minus 1 plus, and our R is 0.085 divided by 12. Whoops, 0.085. And divide by 12. So that's our R right here. And close that up, and we get a negative N power. So it's a negative 240. and then we are dividing by R, the interest rate, 0.085 divided by 12. Alright, so then there's keying this guy in. Okay, now if it just says substitution only, you're done. But be a little bit careful when you key in. Here, you can, this interest rate on the bottom's okay, but up here on top, be careful when you key in. You want to do your 0.085 divided by 12 plus 1. That gets the negative 240 power. Then subtract that answer from 1. You may be okay doing this all in one shot if you use some extra parentheses, and that's fine. Just be careful when you key in that you put parentheses around this guy. And sometimes on some calculators you may have to put an extra set of parentheses that includes the exponent. Okay, that's sometimes why I figure this out, and then I do 1 minus answer. So if you do the calculator work there, you should get this 80,661.59. So please do that, double check. Make sure that you're good on the calculator. Okay, now we're looking at a mortgage table. So this is a 15-year mortgage, $70,000, and we're at 10%, and the monthly compounded monthly, so it's monthly payments, and that payment is $752.22. So you're given that payment. We want to compute the loan table. First line. Well, payment's easy. That's already done for you. $752.22. Okay, and then you want to show how you're getting your entries. Interest is principal times rate times time. So this is PV start amount times R times T. And I am getting that from simple interest rate here, PVRT, because only 1 month goes by. So when you're going from just 1 month in a mortgage table, you're using simple interest. And so our start amount here for that first month is $70,000. And then our interest rate this is monthly interest rate. Okay, so actually our R is 0.10 divided by 12. And so let's see here. So we'll plug that in here, 0.10 divided by 12. And then times our time is 1. And then if you do the calculator work there, you get 583.33. So 583.33. So that's what goes in here. That's your 583. And you need to show me this calculation. Okay, and then principal, remember how this works. Your payment, they subtract off what you pay on interest first, and whatever's left over goes on the balance of the loan. So subtract these two guys. So 752.22 minus 583.33 is equal to 168.89. So that guy goes in here. So that's the part that pays down the loan. So that gets subtracted off of the $70,000. So your new balance then is going to be $70,000 and minus 168.89. And that just takes us down a little bit. That's 69,831. And 11 cents. So that goes in here. Okay, so that's mortgage table. And we're just worrying about that first line. Once you got that pattern, you can repeat it. Okay, so let's see. We're buying a house for $80,000, 15-year mortgage. This is a loan, so you're in the loan category. What's your payment? Monthly payment. So it's asking what your payment is. So we go back here. It's not single deposit, it's not regular savings, it's loan payments. and they're asking what, so we're in this category, and then the question is, what is your payment? So that's this formula, P equals. So let's bring that one over. So I want to see you guys copy these formulas down so I can tell which one you're using. And now let's go ahead and put lay the pieces out here. So you buy a house for $80,000. That's your loan amount. That's PV. Okay, that's the start amount of your loan. And it's a 15-year mortgage. That's going to help us figure N. 9% APR. So APR equals 0.09. And let's see here. What is your monthly payment? So monthly means when we figure this R, we got to divide by 12. So R is going to be 0.09. Divide that guy by 12. And that one works out nice. That says 0.0075. And then our N is, it's 15-year mortgage, and it's 12 months per year. So this is 15 years times 12 months per year is 180 months total. So now we're ready to do our plugins. So PV up on top, 80,000. And then our R, 0.0075. And then downstairs, 1 minus, 1 plus, R is 0.0075. And that gets a negative N power, so it's a negative 180. Okay, so if you do this multiplication on top, you get an even 600. So that works out nice. Oops, not 6,000. And then down on the bottom, if you key this guy in, again, I would do 1.0075, negative 180 power, get that answer, and then do 1 minus answer. But you can key it all in straight across. If you do that, you get 0.73, 945, 0566. And you want to carry those out. If you, if you're copying separate answers, intermediate answers, and then you divide these guys here, you get 81141. So there's your 81141. So that's your monthly payment. Okay, now we're still loan. What is the balance of the loan after 10 years? Okay, so we go back here. It's still loan payments. What is the balance? That's B equals. So we're using this formula down here. So let me bring that guy over. So now we got to plug into the B equals formula. Now notice this one's a substitution only, but I again gave you final answer so you could double check your work. So this is all the same substitutions except for this K. Okay, remember K is the payments made. K is the number of payments made at the time you're checking that balance. So let's see here. We made 10 years of payments. So that's going to be 10 times 12. So that's 120 payments made. So plug in our P here. So payment was the 81141. So that's the answer from part A. Times 1 minus 1 plus R, so 1 plus, and our monthly rate is 0075. And then we get K minus N power on that guy. So K is 120, so K minus N, let's figure that out up here, is going to be the 120 minus N up above is 180. So that's negative 60. So this exponent here is negative 60. And we're dividing that all by our interest rate, which is the 0.0075. Okay, and then again, key this in and double check and make sure that you can get that 390,088. Because I'll, I rotate around, which problems I have you substitute on. All right. Normal payment on a $100,000 mortgage. This is a loan for 30 years is $733. You make payments of $800. Okay, so this is the 30-year payment here, the $733. That's the 30-year payment. That's given to you. You make payments of $800, so you make a higher payment. How long will it take to pay off the loan? How much will you save? Okay, so how long is the question here? So how long? So we know it's a mortgage, so that's a loan. So you go over here, we're in loan payments again. How long is n equals? How long is always asking for that n. It's always the log formulas. And let's get this guy in here. So again, how long is always asking for n. Alright, so let's put some of the pieces in here. So it's a $100,000 mortgage. So that's going to be our loan amount, PV. And then let's see here, our APR is 8%. And we need R. It's going to be our monthly rate. So that's 0.08 divided by 12. And that one's repeating. So let's just leave that as the 0.08 divided by 12. And then our payment here, P, you don't want to use the 733 because if you do that, it's going to tell you your answer is going to be 30 years, 360 months. You want to use the new payment, the 800, the higher payment. So your P is going to be 800. And now we've got all our pieces. So this is going to be negative log quantity 1 minus PV R over P. Close that up and divide by log 1 plus R. What am I doing? I want to do my substitutions. Okay, so up on top we've got PV, our loan amount, 100,000. And times R, which is our 0.08 divided by 12. And then downstairs we've got a P, payment of 800. And down at the bottom, we've got a log 1 plus R, which is our 0.08 divided by 12. Okay, so be careful with the logs here. I would recommend, just calculating the inside first and then take the log of that number. But, if you want to just use extra parentheses, that's okay. So, if you do the 0.08 divided by 12, you get 0.006 repeating, and then times 100,000. And that gives you 666.66, and then divide by 800. And so that gives you 0.83. And then you do, well, it's actually 0.833325. So you got that answer, the 0.83325, and then I would do like 1 minus answer, or write this all out. Okay, so that gives you 0.166 repeating. Okay, so the inside of here of this log is 0.16 repeating. It's 0.16666 repeating. So now, if you still have that in your display, well, it depends on what kind of calculator you've got. You can either hit the log key and it'll give you an answer, or you can do log and then do answer. Press the answer key and it'll take the log of the answer. And then hit your plus or minus key. Or if you got a grapher, put a minus out in front. If you do that for the top, you should get 0.77, 815, 125. Carry out all your decimals if you're doing intermediate answers. And then on the bottom, this is your 0.006 repeating, plus 1 is 1.006 repeating, so you could do log 1.00666666, and that gives you 0.002886 88. And then divide these guys, and you get 269.7. So 269.7 months. Now, if you need the answer in years and months, here I asked for months. If you wanted years and months, if I asked for years and months, just do long division by 12. So 12 into 269.7. This answer, just round it to the nearest tenth, is okay. So 12 goes into 26, that's 2 times, so 24. Bring down 29, and that's another 2. So that's 24, and 57. And 5 times 12 would be 60. Yeah, so let's see, that's a 9. Yeah, 269.7 divided by 12. Yeah, 22.475. Looks like I'm off just a little bit here, because this goes in here, so it's going to be point, and this is 4, which makes 48. And if you go, one more time, you get a 7. So this is 48 up to 57 is 997. 7 times 12 is 84. It's a 47. So this is actually going to be 22.5. But actually, let's see, we want to do, we want to do years and months here. I want to back up here. This is, okay, so 22 years. Yeah, we need to use a remainder. So it goes in 22 even years, and then 5.7 months is left over. So 5.7 months. Okay, so that's what this is, the 5.7. So unless I specifically ask for that, then this is fine. And then the next question is, how much will you save by paying that off early? Do you round it up to the next 100? So we're going to pay off early. So the amount saved here, now this formula is not on the sheet. This is just kind of a common sense formula, is your old total of payments, it's your old N times P, minus your new total payments, new N times P. So what you would have done if you did the original loan, you would have done 360 payments, that's 30 years, and they'd be $733.76. minus, what did you do instead? Well, you did 269.7 payments of this higher amount, $800. Okay, so multiply these two guys together. So this is 264,153.6, and then multiply these, you get 215,760. And subtract 48,393.60. Okay, so that's the amount saved. So you saved almost $50,000. Good deal. Okay, and that was one of our practical financial advice too, was pay an extra $100 a month on your mortgage. This isn't even quite an extra $100, and you're saving a lot of money there. And let's see, on this problem, the only other things I could mention here are, I think I did this on the other practice exam. If it's a credit card balance, that's a loan. So if I would have said you had a $100,000 credit card balance, heaven forbid, or a student loan or something like that, those, that's in the loan category. But then also, if it's an annuity and it's in the payout stage. So if I say that you have an annuity paying out, that's also loan. That's loan in reverse. That's where, again, you give your one lump sum of retirement savings, you loan that to the investment company, they pay you back with interest. So either one of those two terms are still loans, just like a mortgage. Alright, and winding things up. So after you graduate, you get a real job, and you start to save $200 a month in an IRA, save early, and it's giving you 9.5% compounded monthly. So the equivalent rate's 9.5 compounded monthly. Your employer matches your contribution. That means you put in $200 and they put in $200. How much will you have if you retire in 35 years? Okay, so how much will you have is the question. We are saving, and it's per month. So we go over to our formulas. This is regular savings. And they're asking how much will you have. That's future value. That's your end amount. Okay, so we're using future value formula. So bring that guy over. And now let's start filling in some of the pieces here. So we need a payment. Well, your payment is going to be 2 times $200 a month, because your employer matches. You put in $200, they put in $200. That's called a matching contribution. So that's $400. Let's see. We know our APR here, 9.5%. Write that down. So that's 0.095. And 35 years is going to figure our N. We need a monthly rate here. So R is going to be 0.095. And we're dividing by 12. That one's not a nice rate, so let's just leave it as 0.95 divided by 12. And then N is going to be our 35 years, and times 12 months per year. And that is 420. Okay, so now do our plugins. So our payment, $400 a month. And then this will be times 1 plus interest rate, 0.095 divided by 12. That whole thing gets an N power on it. That gets a 420 power. N's 420. Then subtract 1. and then divide by your 0.095, divide by 420. I'm sorry, scratch that. 0.095 divided by 12. Alright, so now we got the calculator work to do. So in here, I would do, 0.095 divided by 12, get an answer, plus 1, get an answer, y to the x or caret 420, get an answer, minus 1 equals. Okay, and that should give you 26.43, 74151. And then on the bottom there, this 0.095 divided by 12, that's a repeating decimal. That turns out to be 0.007916 repeating. So the sixes keep going. It's 9166666. And I forgot our $400 payment here. Got to squeeze that guy in there. Okay, and so we got a 400 out in front here. So divide these two times 400, and you get your end amount, which is 1,335,785.18. Okay. So remember, you want your goal to be 2 to 3 million. So you'd want to be putting away like 800 a month, not 400 a month. How much interest will you earn? Okay, that's the next question. How much interest? So if we go back here, it's still regular savings, but now the question is how much interest. So it's the I equals formula. How much interest? So we take our end amount minus the total of payments. Alright, so end amount is this guy up here. So that's 1,335,785.18. And then minus, we did 420 payments of 400. So 420 times 400. And if you do the calculator work there, you get 1,167,785 and 18. Okay, so that pretty much wraps things up. The only other thing I want to remind you of is practical financial advice. Okay, and some people I've seen get a little creative here in the past. So you need to be specific to get full credit here. But I'm going to ask you the practical financial advice. So some things that we could do here would be like set a retirement goal. And that would be 2 to 3 million. Something else would be to use a budget. Budget your monthly expenses. We talked about that mint.com site. To use a budget, monthly budget. I know you guys used to like to call that a spending plan, because budget sounds so restrictive these days. So you want to devise a spending plan. So you want to control your expenses. Don't spend more than you make. The government still has to learn that lesson. Have an emergency fund. We talked about start saving early. The earlier you start, the better off you're going to be, because you get that exponential growth working for you. So early, start saving as early as possible. 10-10-80. Okay, so that was recognizing, we're just stewarding resources that God has entrusted to us. So give 10%, save 10%, live off 80. Let's see, what else did we have in here? Pay an extra $100 on your mortgage. Okay, pay an extra $100 per month on your mortgage. Or this could be, a student loan or credit card or something like that. It's like, the idea is just don't make the minimum payment, or you're going to get, and that could be in place of this. Don't make the minimum payment because you're going to get charged all the extra interest. And then, let's see, there was another one I was remembering here. Oh yeah, read the fine print. Because remember, credit card companies and banks and stuff, a lot of times, they're trying to make money. So if you don't read all the details here of contracts, then you can get taken. You don't want that to happen. Be careful. Read something before you sign it. If you have questions, ask. To make sure that you're getting the deal that you're supposed to get. If you're getting like free financing or something like that, there's nothing wrong with that. To establish credit, we talked about pay your bills on time. Okay, so that gives you a good list to start on. 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 things in there. Haven't decided exactly how many I'm going to ask you, but I will ask you for several pieces of financial advice, practical financial advice. Is things I want you to take away from this class. Seeing things like, oh gosh, we save $50,000 by making just a little extra payment on our mortgage, and here, oh my goodness, we saved $1 million because, we were disciplined over 40 years. Now this rate's too high, 9.5%. 7.5 would be more reasonable over the 40 years. But, you get the idea. You get that money sense, and that's what I want you, to have here. Another one that Dave Ramsey recommends here is as a long-term goal. We had the emergency fund, so you don't have to charge like emergency expenses. But if you lose your job, you want to save 3 to 6 months of living expenses. In case you were to lose your job. Because you would get some unemployment, but it may not be enough to get by. So that, 3 to 6 months of living expenses, that could take you through a year of trying to find a new job. And, you wouldn't lose everything you own, wouldn't lose your car, wouldn't lose your house. Granted, this is a longer term goal. It takes a while to build up, that kind of money. But that's a good goal to have. All right, I think that about wraps us up here.